Hello there, Mrs. Thompson here, and today we're talking about gas stoichiometry at conditions where it's not at STP. And when it's not at STP, you cannot simply use molar volume and say that 1 mole of that gas is 22.4 liters. Instead, you have to use a combination of stoichiometry and Pivnert. Hardest part in this is deciding which one to use first. So hopefully this will help you in that. Okay, so you'd have to look at your givens. Is it in terms of a solid or is it in terms of a gas? If it's in terms of a solid, you're going to need to use stoichiometry first. If it's in terms of a gas, you use Pivnert first. Your first step, if it's in terms of stoichiometry first, which is the solid, you would use stoichiometry to convert to moles of gas. Then you can plug moles of gas into Pivnert to find the volume of the gas. And remember, these are at conditions not at STP. If it's at STP, you just use gas stoichiometry and molar volume. When you are using Pivnert first, because you're given the volume of a gas, you would use Pivnert to find the moles of that gas. You'd find the N. Then you would use stoichiometry to figure out the mass of the solid. All right, a couple things you need to remember. PV equals nRT is only for gases. Do not plug solids in there. So be aware of what substance you're looking at the time. Another thing is you have to use stoichiometry in order to change it from one substance to another. You have to go through the mole bridge, through moles of given to moles of the unknown. All right, so here's our example. What volume of CO2 forms from 5.25 grams of calcium carbonate at 1 atmosphere and 25 degrees Celsius? Pretty close to STP. What's wrong with this is the temperature. It's 25 degrees and not 0 degrees Celsius. Okay. All right, so my given here is 5.25 grams of calcium carbonate. And my unknown here is the liters or volume of CO2. And it's not at STP. Okay, since I'm given the number information about calcium carbonate, which is a solid, get the balanced equation, you can tell it's solid. Then I'm going to need to use stoichiometry first. So since I'm going from the solid to the gas, I use stoich first. And what I'll do is I will convert this solid into moles of CO2, the gas that I'm interested in. So let's do that. 5.25 grams of calcium carbonate. We'll go from grams of calcium carbonate to moles of calcium carbonate, and then to moles of CO2. So the molar mass of calcium carbonate is 100.09 grams in every 1 mole of calcium carbonate. That cancels out grams. And then we have the next step, which is the mole ratio step. That's moles of unknown on the top and moles of given on the bottom. I use the coefficients in the balanced equation to get that ratio, and it's a 1-to-1 ratio. That cancels, and I'm left with 0.0525 moles. I stop here at moles. I don't go to grams. I can't go to liters because it's not at STP. So I'm going to take these 0.0525 moles, and I'm going to plug it into Pivnert. So here we go. We're going to separate this out into the given and the work. So this is the same problem, okay? Just the second part of it. Let's list the givens for Pivnert now. That's 1 atmosphere, unknown volume, the number of moles of CO2 we've converted to figure that out. The temperature is 25 degrees Celsius, which I convert to Kelvin, and then I get 298. And R, I have in my back pocket. Need to write it all, just put a check mark. All right, so my equation, PV equals nRT. Change that into an equation that solves for volume. That would look like this. Volume is equal to nRT over P. plug everything into the equation. Okay, so nothing new. Hopefully that looks all familiar. Plug stuff in. Moles cancel. Kelvin cancels. Atmospheres cancel. And I'm left with liters. So it's 1.28 liters of CO2 as my final answer. I boxed this one because this is the answer that they're asking for. What's the volume of CO2? That's the volume of CO2. Example number 2. How many grams of aluminum oxide are formed from 15 liters of oxygen at 0.960 atmospheres and 21 degrees Celsius? And then a balanced equation is given. So let's think about what's given in terms of the substance. So in terms of the substance, we have 15 liters of oxygen, and we're trying to find the grams of aluminum oxide. Okay, which means we're going from the gas to the solid. When you start with the gas information, you use Pivnert first. Okay, so let's do that. List our givens and do the work. So the pressure is 0.960 atmospheres. The volume is 15 liters. The number of moles are unknown. In fact, they're always unknown when you start with Pivnert first. And then the temperature would be 21 degrees Celsius, which we would need to convert to Kelvin. And then R, got in my back pocket, it's a check mark. All right, so here's our equation, PV equals nRT. We need to rearrange that to solve for N. So hopefully you remember how to do that. And then we can plug everything in. 0.960 atmospheres times 15 liters over 0.0821 liters times all the units times 294 Kelvin. Now let's just figure out which units cancel. Atmospheres are on top and on bottom here. Liters cancel, Kelvin cancels, and I'm left with mole. Okay, this one's kind of strange. It looks kind of funny. I just wanted to show you this. Mole, our answer mole, ends up on the top because what we have is 1, because the units on top canceled. I'm just showing you the unit part, over 1, because those liters and atmospheres canceled as well, over mole. So this is 1 over mole. So it's like the inverse of 1 over mole, which would be mole. Or you could say, in order to move mole to the top, I would multiply by mole on top and bottom, and so you would get mole on top. All right, and so that gives me 0.597 moles of O2, which means I'm going to take this and I'm going to use stoichiometry now to figure out the grams of aluminum oxide. All right, so here we go. So what I'm saying is we're now using the 0.597 and we're changing it to grams of aluminum oxide. So 0.597 moles, and I use mole ratio first since I'm starting with moles. Balanced equation is where I got the coefficients there. That cancels, and then I say 1 mole is 101.96 grams of aluminum oxide. And that cancels, and I get 40.6 grams of aluminum oxide. Okay, so that is my final answer since the problem is asking me for grams of aluminum oxide. Okay, the difficult thing in here in these problems is not the math, it's just knowing which step to use when. So be careful. If you're given information about the gas, you use Pivnert first because that's for gases. And if you're given information about the solid, well, you're going to have to use stoichiometry to change it to the gas. So then you can use Pivnert. All right. Hopefully you understood this lesson. I will see you soon.